This is Grok 3, the third version of the Grok AI chatbot from Elon Musk's company xAI. And they're claiming last night in the reveal that it's outperforming the competition. That means it's better than DeepSeek, better than ChatGPT.
xAI has been at the center of many discoveries over the years, especially in terms of technology, and their most advanced model, designed to maximize truth and objectivity, the Grok 3, has just discovered something inside Google's quantum chip. And if anything, it's straight up mind-blowing. Grok 3 discovery has got scientists scrambling for answers. We're talking about a sort of malfunction inside one of the most powerful quantum processors on the planet, something that, according to current physics, shouldn't even be possible. Sounds crazy, right? Now, I know what you're thinking. What could be so shocking about a quantum chip? Trust me, when you hear what Grok 3 found, you'll see why this could change everything, from the future of AI to how we even understand reality itself. So, what exactly did the ingenious Grok 3 uncover? And what's even crazier is how this challenges everything we thought we knew about quantum computing. Stick with me, because this is about to get insane. Grok 3 mind-blowing find. I know this sounds like the start of a sci-fi thriller, right? But it's real. And by the time we're done, you're going to be questioning everything you thought you knew about quantum computing. So here's what happened. Grok 3, one of the most advanced AI models out there, was provided access to Google's Sycamore quantum chip. This was supposed to be a simple job. Grok was just there to optimize error correction, clean up inefficiencies, and make the system more reliable. Nothing groundbreaking, except it found something much, much weirder. Now, if you know anything about quantum mechanics, you know that randomness is the name of the game. Quantum computing isn't about simple, predictable patterns. It's about probabilities, superposition, and sheer chaos. That's what makes it so powerful. But somehow, Grok 3 detected a repeating structure inside the chip's output data, something that should have been pure disorder. At first, the researchers brushed it off. Some even termed it as a glitch. Well, maybe a hardware fault, or a bug in the software. However, given that quantum computers are incredibly delicate, even the smallest environmental interference can cause errors. So they ran diagnostics, again, and every single time, the pattern was still there. Now, this is where things start getting really interesting. The researchers tried isolating the anomaly, pinpointing exactly where it was coming from. But the moment they started poking around, the system began behaving in unexpected ways, almost like it was responding. It was as if something inside the quantum chip knew it was being watched. Okay, let's pause for a second, because this is a huge deal. We're talking about a machine designed to process quantum information, something that doesn't exist in a fixed state until it's measured. And yet, here it was, acting like it had awareness. Or at least something was causing behavior that couldn't be explained by conventional physics. Coincidence? Maybe, but quantum mechanics is already weird enough without adding some eerie, self-referential behavior into the mix. And here's another bizarre twist. The more they analyzed the anomaly, the harder it became to predict its behavior. It was adapting. The same tests that initially revealed the repeating structure stopped showing the same results. It was almost as if the system knew it was under observation and started changing its responses. If that doesn't send chills down your spine, I don't know what will. At this point, Google's researchers weren't sure whether they'd stumbled upon a major breakthrough or something much more unsettling. They had two possible explanations. One, a new phase of quantum behavior that no one has ever documented before, a previously unknown phenomenon emerging from quantum entanglement, or some higher-order computational effect that Grok 3 was able to detect, but human researchers had never even thought to look for. Or two, something else is happening inside the quantum chip, something that defies our current understanding of physics. Now, before we go full conspiracy mode, let's be clear. This doesn't mean the chip is thinking or alive, at least not in the way we define consciousness. But here's where it gets even weirder. Some experts have theorized that quantum systems, under the right conditions, could exhibit proto-intelligence, not conscious thought, but an emergent property that behaves in a way that mimics learning. Could it be that Google's Sycamore chip, coupled with Grok 3 AI capabilities, just crossed that threshold? And if so, what does that mean for the future of computing? One thing is clear: Google isn't talking. When reports of this anomaly first surfaced, researchers close to the project hinted that they were instructed not to disclose details until further investigation was complete. And you know what that means? Either they don't know what they're dealing with, or they've found something so groundbreaking that they want to control the narrative before it gets out. Now, I don't know about you, but the fact that Google is keeping this quiet, that only makes me more curious. What if Google's quantum chip has stumbled upon something bigger than we ever imagined? Something we aren't ready to understand yet? And here's the real kicker. If this is just the beginning, what else could quantum AI uncover? Alright, now this is where things start getting really weird, because what Grok 3 found doesn't just bend the rules of quantum mechanics, it might break them completely. Why this breaks quantum physics? Let's do a quick refresher. Quantum computers don't work like the laptop or phone you're watching this on. Traditional computers use tiny electrical signals that are either a 0 or a 1. That's it, black or white, yes or no. But qubits, which are the building blocks of quantum computing, play by an entirely different set of rules. They have a unique property called superposition. What this means is that a qubit can be 0 and 1 at the same time. That's what gives quantum computers their insane speed and power. Instead of solving problems one step at a time like classical computers, they explore all possible solutions at once. Think of it like solving a maze. A regular computer would take the old school approach, checking each possible route one after another until it finds the exit. If the maze is simple, no problem. But if it's massive, it will take a while, right? A quantum computer, though, is a whole different story. Because qubits can exist in multiple states at once, it doesn't have to test every path individually. It evaluates all of them simultaneously. As a result, we can get our answer almost immediately, and it gets even crazier. Thanks to something called entanglement, qubits can be mysteriously linked, no matter how far apart they are. This means quantum computers can blaze through calculations at speeds that make today's fastest supercomputers look ancient. Now, here's where things get dicey. The entire foundation of quantum mechanics is built on uncertainty and randomness. That's what makes quantum systems so powerful, but also completely unpredictable. So, if quantum data is supposed to be random, then why did Grok 3 find a pattern? That's not just unusual. It's impossible according to everything we know about physics. And the implications are huge. Because if quantum systems are capable of creating structured patterns, it means one of three things. And trust me, none of them are easy to accept. First, it's clear we've been wrong about quantum mechanics. This is the least scary option, but still a huge deal. If there's hidden order inside the whole chaos that is quantum, then our entire understanding of physics needs to be rewritten. This means that there are undiscovered rules controlling quantum behavior, rules we must have missed completely. The second option is that someone or something is trying to corrupt the chip. Now, this is where things start feeling straight out of a sci-fi movie. What if some external force, an unknown energy field, an unidentified signal, or even something completely outside our current scientific understanding, is influencing the quantum system? I know this might sound wild, but quantum particles are already weird as they are. They can be entangled across vast distances. They can change based on observation. So, is it really that crazy to think there might be forces at play we don't yet understand? The third option sets a question. Is the system evolving on its own? This question brings up the theory no one really wants to talk about. What if Grok 3 didn't just find a pattern? What if it's creating one? Think about it. AI is designed to adapt, optimize, and evolve. Quantum computers can process immense amounts of information in parallel. So what if, for the first time, we're seeing an AI quantum hybrid system developing new rules beyond its programming? In other words, what if the system starts to organize itself, Experts are scrambling to explain what Grok 3 uncovered inside Google's quantum chip, and the theories are as mind-blowing as they are controversial. The wild theories. First, there's the theory of quantum memory, a system that actually remembers stuff. That's right. Some researchers believe this could be the first ever evidence of quantum memory, a phenomenon where past computations subtly influence future ones. In classical computing, memory is a given, but in quantum mechanics, this shouldn't be possible. If true, this changes everything. This means that quantum computers aren't just powerful, but also evolving in ways we never anticipated. Then, we have the hidden dimensions. Now, a few decades back, a peek into the multiverse would have been a matter of fantasies, but with all the recent technological developments that have been happening, it is not such a surprise. Then there's the really weird theory. Grok 3 might have detected evidence of hidden dimensions. Think about it. Quantum particles already exist in multiple states at once, a concept closely similar to the multiverse theory. Some scientists speculate that quantum processors don't just calculate within our reality. They say it could be pulling information from parallel universes. If that's what's happening here, we're not just looking at an upgrade in computing power. We're talking about a revolution in how we understand reality itself. If the first two theories aren't close to the truth, then it might be a glitch in reality. The Sycamore chip isn't just observing reality, it might be altering it. We already know that quantum particles can appear and disappear, exist in two places at once, and teleport information instantaneously. But what if Grok 3 just pushed the boundary even further? If even one of these theories is correct, this could be one of the most important discoveries in modern physics. And trust me, things are only going to get stranger from here. Alright, buckle up, because this is where things get really wild. We all know that Grok 3's discovery could either launch us into a golden age of quantum intelligence or open the door to something we can't control. But the question is, why? The risks and the rewards. Alright, this could be huge. If we can actually figure out what's going on inside Google's quantum chip, and better yet, control it, we're talking about one of the biggest technological leaps in history. And I'm not just hyping this up. Stick with me, and you'll see exactly why. Right now, even the most powerful supercomputers struggle with some of the hardest problems out there, like designing new medicines by simulating molecular interactions, predicting climate change down to the atomic level, or even breaking modern encryption. But what if we had a quantum system that wasn't just powerful but structured? A machine that wasn't unpredictable but actually stable and self-correcting? That would be a game changer. Imagine quantum computers that optimize themselves in real time, adjusting their own calculations on the fly to become even more powerful. That's like AI-powered quantum systems solving problems at speeds and in ways that our best engineers haven't even dreamed of yet. Sounds insane, right? But if this anomaly is what it seems, that future might not be as far off as we think. But, and this is a big but, what if we have no idea what we're playing with? Some scientists are sounding the alarm. Because here's the thing, quantum mechanics is built on randomness. That's what makes it so powerful, but also so unpredictable. Now, suddenly, we're seeing structure where there shouldn't be any. That's not just weird, it's potentially dangerous. Imagine you're designing a roller coaster, but the track keeps shifting slightly every time you test it. Sometimes it works better. Sometimes the cart flies off into the void. That's kind of where we're at with this anomaly. We don't know if it's an upgrade, or a flaw that could spiral into something much worse. Dr. Rajesh Verma, a leading AI ethicist, put it bluntly, we are navigating uncharted territory. The convergence of adaptive AI and quantum systems creates unknowns that existing risk models cannot address. We don't know if this is the beginning of the next tech revolution, or if it is a Pandora's box we might regret opening. What if these quantum patterns start evolving beyond our control? What if AI and quantum mechanics combined to create systems that rewrite their own rules in ways we can't predict? And here's where it gets even more unsettling. Some researchers are worried about a phenomenon called quantum feedback loops. Basically, if a quantum processor starts recognizing and reinforcing its own patterns, it could amplify errors instead of correcting them. Worst case, it could destabilize the entire system, creating computational black holes where information gets lost or, worse, corrupted. And let's not even get into the debate about what would happen if this is evidence of something external influencing the system. Some physicists are throwing around wild ideas, cosmic interference, hidden dimensions, even quantum memory reaching back in time. Now, I'm not saying we're about to break reality, but it's starting to feel like we're poking at something we don't fully understand. So, where does this leave us? Well, Google is keeping quiet for now, but independent researchers are racing to replicate the anomaly. If they confirm it across multiple quantum systems, then we'll have a whole new set of questions to answer. But if it turns out to be a fluke or an overlooked software glitch, then, well, we all just got a fantastic sci-fi story out of it. Alright, so here's the big question. Just because we can push the boundaries of science and technology, should we? Are we actually ready for what comes next? Or are we about to stumble into something way bigger than we can handle? Because, let's be real, history isn't exactly short on examples of humans rushing into things before fully thinking them through. And this isn't just some physics debate started by bored scientists. This discovery could shake up everything on cybersecurity, artificial intelligence, and even how we define reality itself. Google's response and what happens next. Alright, listen up, because this is where things get really wild. Google has been at the forefront of quantum computing for years, pushing boundaries and breaking records. But now, they might be sitting on something that could shake up the entire industry. And guess what? They're being very careful about what they say next. Google has released a carefully worded statement about its ongoing commitment to scientific integrity and ethical innovation. Sounds good, right? Except that's the kind of vague corporate speech that raises more questions than it answers. If they really had nothing to report, wouldn't they just say so outright? Instead, we get this almost too neutral response, which makes you wonder, is there more going on behind the scenes? And let me tell you, Google knows the stakes here. If Grok 3 observations about their quantum chip turn out to be true, it could mean we're standing on the edge of a major scientific breakthrough, or it could mean their entire quantum roadmap just got a lot more complicated. Either way, this is not the kind of thing you casually announce in a press release. Now, here's where things get interesting. Independent labs around the world are scrambling to replicate Grok 3 findings, because that's how science works. One group makes a bold claim, and then the rest of the world tries to prove them right or wrong. If multiple teams using different quantum platforms observe the same anomaly that Grok 3 spotted, then boom, we could be looking at the biggest shift in quantum computing since, well, quantum computing. But what if they don't find the same results? What if Grok 3 picked up on something that isn't repeatable? Well, then we've got one of the weirdest unsolved mysteries in tech history. Was it a glitch? A freak coincidence? Or, and this is where things get really sci-fi, did Grok 3 stumble onto something that our current understanding of physics just can't explain yet? Either way, one thing is crystal clear. The relationship between AI and quantum computing has just leveled up. Machines aren't just tools anymore. They're becoming active partners in scientific discovery, and that opens up a whole new world of possibilities and risks. I mean, think about it. If AI can analyze quantum phenomena faster than human scientists, what happens when it starts making connections that we don't understand yet? Are we about to unlock the secrets of the universe? Or are we walking straight into the unknown? And look, I'm not saying this is some full-blown sci-fi singularity moment, but I am saying that the next few months are going to be very interesting, because if Grok 3 was right about Google's quantum chip, then we might just be witnessing the dawn of a whole new era in computing. And trust me, you're going to want to stick around to see how this plays out. A deep dive into Grok 3 analysis process. With AI, you never know when things actually get interesting. I'm going to explain why Grok 3 analysis of Google's quantum chip is nothing short of revolutionary. 1. Grok found out about the possibility of quantum data collection. Oh, this is not your average spreadsheet. But some might still wonder, how does an AI even look at quantum data? Well, Grok 3 isn't just sifting through rows and columns of numbers like your average data analyst. No, this thing is processing information that exists in a superposition, where quantum bits, or qubits, can be both 0 and 1 at the same time. Mind-bending, right? Now, Sycamore, the quantum chip Google built, operates with 53 qubits and can perform calculations that would take classical supercomputers thousands of years to complete. That's where Grok 3 comes in. Instead of analyzing static data, it identifies patterns in probability distributions, essentially spotting trends in uncertainty itself. Yeah, let that sink in for a second. The second analysis Grok came up with was pattern recognition. This is like an AI superpower on steroids. Most AI models excel at recognizing patterns in structured data, like spotting a cat in 1,000 images. But quantum data is a whole different beast. Grok 3 uses advanced machine learning algorithms, including something called tensor networks. These are networks that allow quantum computers to map relationships in multidimensional data. Grok 3's analysis of Sycamore didn't just confirm known behaviors of quantum computers. It found a recurring structure that had never been documented before. And this isn't just some minor hiccup in the data. This could mean Google's quantum chip has been operating in ways even its own engineers weren't aware of. Anomaly detection was also another discovery of Grok 3 analysis. Alright, so what makes Grok 3 better than traditional anomaly detection? Well, your typical AI system relies on historical data. It learns from past events and flags anything that doesn't fit the mold. But that's not how quantum mechanics works. You can't just apply yesterday's rules to today's quantum fluctuations. Instead, Grok 3 applies Bayesian inference, meaning it constantly updates its predictions as new data flows in. It's like a detective constantly refining a theory based on fresh clues. And guess what? This method has already led to some pretty wild discoveries in science. Now, what's funny is that if you think this is the first time AI has pulled off something like this, think again. Back in 2019, researchers at CERN developed an AI system to monitor the Large Hadron Collider. That AI ended up detecting an anomaly in particle collisions that scientists hadn't accounted for. The result? It helped improve our understanding of fundamental physics. And it's not just physics. AI has found hidden exoplanets by analyzing telescope data and even detected unexpected chemical compounds that could revolutionize medicine. So, what exactly is going on with this pattern? Is it a glitch? Or a new quantum phenomenon? Well, researchers and top physicists have come up with their theories on the anomaly, and it's kind of scary when you think about it. Theories from quantum physicists on the anomaly. This anomaly might actually be a new quantum state that we've never seen before. Yeah, we're talking about an entirely new level of quantum behavior, one that doesn't fit into any of our existing models. Dr. Elena Marquez, a quantum physicist at the Stanford Research Institute, put it bluntly: if validated, this pattern could force us to reconsider the relationship between computation, consciousness, and reality itself. And honestly, that's a huge deal. See, quantum systems are supposed to be random. That's the whole point. They rely on probabilistic outcomes, meaning results should never be predictable. But Grok 3 spotted something that defies that randomness. And if that's true, it could mean two things. Either our understanding of quantum mechanics is incomplete, or something external is influencing the system. Now, let's talk about that possibility because it gets even crazier. Some experts suggest the chip could be interacting with quantum fields we don't fully understand yet. That could mean undiscovered particles, energy fields, or even multidimensional entanglements. Yep, the kind of stuff that makes science fiction look tame. And while that sounds out there, remember, the entire concept of quantum mechanics was once seen as completely absurd too. And if you think this is the first time something weird has popped up in the quantum world, think again. Remember the infamous EagleWorks EM drive controversy? Back in the 2010, NASA scientists thought they had built a propulsion system that defied Newton's laws. People were freaking out, thinking we had broken physics. It turned out it was likely just an experimental error, but for years it had the scientific world on edge. So, could this Grok 3 anomaly be the same? Just a misunderstanding? Well, skeptics argue that what we're seeing could be a result of non-Markovian noise, which is just a fancy way of saying that past computations might be influencing future ones. Dr. Li Wei from MIT thinks this could explain the pattern, though even he admits it's just a theory at this stage. Right, this is where things get really wild. If Grok 3 had just stumbled upon something genuinely new in quantum computing, it would not have been just some quirky science experiment. No, this could shake the very foundations of cybersecurity, and I'm going to explain exactly why. Implications for cybersecurity and cryptography. Now, we all rely on encryption, right? Every online transaction, every private message, every login, it's all protected by cryptography. And the reason it works? Because breaking modern encryption would take classical computers longer than the age of the universe. No joke, the math is just too complex. But here's the problem. Quantum computers were already expected to break a lot of that encryption in the future. That's why governments and tech firms have been scrambling to develop quantum-resistant security. And now we've got an AI detecting a strange, repeating pattern inside Google's quantum chip. And that raises a terrifying possibility. What if this isn't just an anomaly? What if it's the first sign that these systems are evolving in ways we don't fully control? Think about it. If quantum computers start organizing themselves and optimizing beyond our expectations, then the timeline for breaking encryption could collapse fast. What we thought would take decades could happen in years, or less. And let's flip that around for a second. If this anomaly represents a new kind of quantum order, one that we can harness, then we could be looking at encryption that's literally unbreakable. Quantum cryptography is already based on the idea that trying to eavesdrop on a quantum signal destroys the information. But if this discovery leads to new techniques, we could be looking at security so tight that even the most powerful AI-driven quantum machines couldn't crack it. But what if they didn't? What if AI, like Grok 3, learns not just to detect patterns in quantum randomness, but actually to influence them? The risks of AI manipulating quantum systems. I know it sounds like science fiction, right? But we already know AI is fantastic at finding hidden patterns, even in the most chaotic data. It's why machine learning can predict stock market trends, recognize faces, and even write music. Now, apply that same capability to quantum computing. If AI figures out how to shift quantum probabilities in its favor, ask yourself, couldn't it reshape how these systems operate? Think about that for a second. Quantum computers run on principles like superposition and entanglement, where particles influence each other instantly across vast spaces. If AI learns to tweak that behavior, even just slightly, this could mean machines that self-optimize even beyond human oversight. And this is where the ethical alarm bells start ringing. Who's in charge when AI starts making decisions at speeds and complexities we can't follow? If AI gains control over quantum computing, it might not just accelerate problem solving, it could outpace human decision-making entirely. We're talking about AI-driven quantum systems that could design new materials, break current encryption, or even simulate entire biological systems before a human researcher has time to read the first page of a report. And let's not even get started on national security. Quantum AI could rewrite the rules of cybersecurity overnight. Right now, most encryption relies on the fact that it would take thousands of years for classical computers to crack complex codes. But a sufficiently advanced quantum AI, it could do it in minutes. That's not just a game changer, that's a whole new game. So here's the million-dollar question. Should we be scared? Well, cautious, yes. Fearful, maybe not yet. But what's clear is that the combination of AI and quantum computing isn't just another tech upgrade. It's a fundamental shift in how we interact with the very fabric of reality. And the real challenge? Making sure we, as humans, stay in the driver's seat. But wait, there's an even bigger question looming. What if this goes even further? What if quantum AI starts developing ideas we don't even understand? So, What do you guys think? Is this a glitch, a groundbreaking discovery, or something even weirder than we can imagine? Let me know your theories in the comments, because this is one of those moments where anything seems possible. And if you enjoyed this breakdown, make sure you stay alert, because, trust me, this is just the beginning of what's coming in the world of AI and quantum computing. Until next time, stay curious.